Welcome back to the IIT PAL lectures on mathematics, and today's lecture is going to be once again on the binomial theorem and its applications. This is the sixth lecture for the binomial theorem and problems of the binomial theorem. Okay. So, we have done quite a few problems in the past. We have solved some problems related to integral part, fractional part. We have done a variety of binomial expansions. Today we are going to do a few more, and these are probably some of the harder problems. Okay. So, among the harder problems, we will start with some identities. Okay. So, we have done a few identities a long time back, but this is once again going back to a few identities, because these are the harder ones. Okay. So, one popular identity is this C 0 plus C 1 times C 1 plus C 2 times C 2 plus C 3 and so on, all the way till C n minus 1 plus C n. And you have to show that this is equal to C 0 times C 1 times C 2 all the way till C n divided by n factorial times n plus 1 whole power n. So, this is a complicated one, but if you rack your brains, you are not going to find a straightforward way to do this expansion, right. But the answer lies somewhere else. The answer actually lies in the very first class when we introduced the binomial theorem, even before we introduced the binomial theorem. So, the answer lies in Pascal's triangle. All right. So, think of the following. This point was 1 C 0, this is 2 C 0, 2 C 3 C 0, 4 C 0, 5 C 0. So, this is you are placing, you are giving a new light, throwing a new light on the Pascal's triangle, and this is because we have already done 5 lectures in between Pascal's triangle and today, right. I am sorry, this is 0 C 0. Actually, I will not correct all of this, let me just add one more dot over here. That will be fine. Yeah. So, this is 1 C 0, the top one is 0 C 0, it is not really that important. This is 1 C 1, 2 C 1, 2 C 2, 3 C 1, 3 C 2, 3 C 3, 4 C 4, 5 C 5 and so on, right. And what was the property of Pascal's triangle? The property was that if I want to compute any one of these dots, all I have to do is add this one and this one. Okay. Look over here, you see the resemblance, you see why we are going to Pascal's triangle. Okay. So, for example, 5 C 2, this is 5 C 2 is equal to 4 C 1 plus 4 C 2. Okay. So, in that case, can you tell me what is C 0 plus C 1? Now, we are talking about n C 0. right. So, NC0, so if this is my NC0 and if this is NC1, then these two are going to add and give me the next row in the Pascal's triangle, which is going to be n plus 1 C 1. Okay. Then NC1 is going to add with the next number, which is NC2, and that is going to give me n plus 1 C 2. All right. So, this complicated thing is nothing but NC0 plus NC1 is n plus 1 C1, NC1 plus NC2 is n plus 1 C2, NC2 plus NC3 is n plus 1 C3, and so on all the way, sorry, this is a multiply till n plus 1 NC n minus 1 plus NC n, right, that is equal to n plus 1 C n. Is this fine? So far so good, and if you have gone this far, the remaining part is trivial. Okay. So, if you have gone this far, the rest of it is very easy. All you have to do is break it up. N plus 1 C1 is factorial n plus 1, which happens to be n plus 1 times factorial n divided by, in the denominator you have got factorial 1 and you have got factorial n, but instead of writing n factorial n, I am going to write factorial n minus 1 times n. And then n plus 1 C2 is again n plus 1 times factorial n divided by factorial 2 times factorial, oh no, yeah, factorial n minus 1, and instead of writing factorial n minus 1, you could write it as factorial n minus 2 multiplied by n minus 1, and so on and so forth, right, all the way till the end. At the end you have n plus 1 C n, which is n plus 1 times n factorial divided by n factorial and 1 factorial. So, instead of 1 factorial, I am going to write 0 factorial times 1. So, there are n terms, you have got n plus 1 out of all these n terms. So, all of these are going to become n plus 1 whole power n, and then the way I have written it smartly, right, this portion is n C1, right, this portion is n C2, this portion is next one you will get n C3, and so on all the way till n C n. Okay. So, you have got all of those C1, C2 all the way till Cn, and then here you have got an n into n minus 1 into all the way down to 1. So, you have got n factorial, and C0 is superfluous, C0 is equal to 1. So, that proves the identity, right. Think about it, you can try not using Pascal's theorem and not use this insight, you will be pretty stuck with this problem. Okay. So, this was one example of a hard problem. So, here you have to think a little laterally, right, you have to go back to Pascal's theorem to figure out the sum of two coefficients, two consecutive coefficients. All right, another example. Okay, how are you going to do this? This actually is not that hard. How will you do this one? Any guesses? N into n plus 1 by 2. If that is the answer, right, if you look at the answer is n into n plus 1 by 2. That is a very familiar answer. There is a clue there. What is the clue? The clue is that this should look like maybe this is going to look like 1 plus 2 plus 3 plus 4 plus all the way till n, maybe. Okay? And if that is the case, then we are done. Maybe that is not it, but if that is the case, then we are done. Okay, let us check, let us try it out. C1 by C0, is it 1? Yes, it is. But C2 by C1 is not 1, is it? No, C2 by C1 is not 1. N C2 divided by N C1, okay, that is not 1. C1 by C0 is also not 1. C1 is N, yeah, sorry, correction, C1 is N. So, if this is N, look at it, the numerator is going from C1 to C2 to C3, it is increasing, the denominator is also increasing. Okay. So, it could be, it just could be that the whole thing is dropping all the way from n to 1. So, maybe it is a backward sequence, C1 by C0 is n, maybe this is n minus 1, this is n minus 2 all the way till over here where maybe it is 1. Could that be the case? Let us see, right, let us see. So, if you look at C1, if I look at let us say CR by CR minus 1, what is that equal to? Oh, by the way, this is not C, this is R times CR by CR minus 1, that is the rth term in this series. What is CR? CR is factorial n by factorial r by factorial n minus r. And what is CR minus 1? CR minus 1 is factorial n by factorial r minus 1 by factorial n minus r plus 1. And then of course, n factorial cancels out, r times r minus 1 factorial by r factorial cancels out, and all you are left with is n minus r plus 1 factorial by n minus r factorial, and n minus r plus 1 is just one more than n minus r, which means this is equal to n minus r plus 1. So, this is the rth term, the rth term evaluates to n minus r plus 1. So, whichth term is this? This is 1th term, right, CR, right, C1 by C0, 1 times C1 by C0. So, the 1th term is going to be n minus 1 plus 1, which is n. So, this term is evaluating to n. The next term is the 2th term, n minus 2 plus 1, which is n minus 1. The third term r equal to 3 n minus 3 plus 1. The fourth term will be n minus 3 all the way till the nth term n minus n plus 1. So, this is a decreasing sequence. So, it is as if 1 plus 2 backwards, if you look, you get 1 plus 2 plus 3 all the way till n. If you look forwards, it is a decreasing sequence, and this obviously is equal to n into n plus 1 by 2. Okay. So, this is a trick question. It looks tricky, it is not that tricky. Let us try another one. Okay. So, look, earlier we had done a problem with which looked like, if you recollect, we had done a problem earlier which looked like this: C1 plus 2C2 plus 3C3 all the way till NCn is equal to n into 2 power n minus 1. Earlier we had done something like this. How did we do it? You remember how we did it? We looked at 1 plus x whole power n, and then we did a differentiation of 1 plus x whole power n, right. That gave me n x power n minus 1, n into 1 plus x whole power n minus 1, and then I plugged in x equal to 1. So, this was really n into 1 plus x whole power n minus 1 with x equal to 1. Okay. That is how we had arrived at this result. But look, here the coefficients were increasing, right. The coefficient of C2 was increasing, 2C2, 3C3 and so on. It reminded you of a differentiation. Here you are getting by 2, by 3, by 4, and what does this remind you of? Yes, what does it remind you of? It reminds you of integration, the opposite of differentiation. Okay. So, the clue over here is that you have to integrate, not differentiate, and then maybe later on you can plug in x equal to 1, or we will see what needs to be plugged in later on. But the clue is you have to integrate. Okay. Now, integration is always a little complicated, right. Why is it complicated? Because you have an arbitrary constant. Whenever you talk about integration, integral of x dx is x squared by 2 plus an arbitrary constant, and that arbitrary constant is something very irritating, right. Why is it annoying? Because if I have two sides and I integrate, let us say I have some equation, some identity, right. I just multiply both sides by dx and do an integral. Will the two answers necessarily be equal? No. Why? Because there could be some arbitrary constant here, there could be some other arbitrary constant here, which means that these two integrals need not be exactly equal to each other. Okay. So, this is not correct. Okay. So, that is a little bit of a problem. So, even before we start this, right, the clue was integration, but whenever you have to do integrals, you have to remember that if you just integrate two sides of an identity, you do not always get an identity. Okay. It is a little problematic. what do we do? How do you correct for these constants? How do you fix the okay, I won't use C1, C2, sorry, K1, K2. Okay. How do you get rid of the arbitrary constant? You have to use a definite integral and not an indefinite integral. Okay. That will fix the problem. So, let us try 1 plus x whole power n, and what is this equal to? This is equal to C0 plus C1 x plus C2 x squared plus C3 x cube plus dot 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 all the way till Cn x power n. This is something that we know. And now what we are going to do is, we are going to integrate both sides using a definite integral. So, let us say I integrate 1 plus x whole power n dx from x equal to 0 to x equal to p. Then the right hand side also I am going to integrate definite integration. Okay. So far so good. This is equal. A definite integral, it works fine. Indefinite integral does not work fine. Okay. So, let us do the definite integral of the left hand side, right. How do you do it? You first do an indefinite integral 1 plus x whole power n plus 1 by n plus 1. Is that it? How do you check if your integral is correct? By doing a differentiation. If you differentiate this, do I get that one back? You check, you differentiate n plus 1 times 1 plus x whole power n divided by n plus 1. So, it nicely cancels out. So, indeed the integral of this is therefore equal to this, but this integral you have to take it from 0 to p, and if you plug in 0, if you plug in p, you get 1 plus p. Okay. We do not really need p, right. We can plug in p equal to 1. Let us not do p. So, let us work with p equal to 1. So, we are going to integrate from 0 to 1. 0 to 1, if I plug in x equal to 1, what do I get? 2 power n plus 1 by n plus 1, and if I plug in x equal to 0, I get 1 by n plus 1. Okay. And why I did this was because of the question. The questions look like this: 2 power n plus 1 minus 1 the whole divided by n plus 1. Look over here, 2 power n plus 1 by n plus 1 minus 1 by n plus 1. So, I have arrived at the question, right. That is why I plugged in p equal to 1 over there. Okay. So, the left hand side evaluates to my question, very nice. Now, all I have to do is work out the right hand side. this is what I have. Okay, I expanded the sum, and of course, that works out to C0 times x, right, and you plug in x equal to 1, x equal to 0, you get just 1. C1 times x squared by 2, plug in x equal to 0, you get 0, x equal to 1, you get 1. C2 times x cube by 3, okay, straightforward. C0 plus C1 by 2, C2 by 3, C3 by 4, Cn by n plus 1. That is exactly what you have got. Okay. The key over here was you have to do a definite integral, not an indefinite integral, because indefinite integral means you are in for good amount of trouble, and it is not always correct. All right. Similar question, we are going to do one more, and then we are going to try to solve some more JEE problems. And you look at the right hand side, you know that first of all you have to do an integral divided by n plus 1, then you have to do a definite integral because there is a minus 1 by n plus 1, and thirdly you are not going to plug in the limit of 1, right. It looks like this is going to be some other limit. Okay. When you did it last time, you had 1 plus x n plus 1 whole power n plus 1 by n plus 1. When you plugged in a 1 over here, you got 2 power n plus 1. Here you have got 3 power n plus 1, which means that you are going to start from 0, that will give you the second term, and end at 1 plus x, you want 3. So, x has to be 2. Right. So, the limits, all you have to do is change the limits. You have to go from 0 to 2 and you are done, because that is going to give you the right hand side. Okay. Just check that that is indeed the case. 1 plus x whole power n dx is equal to 1 plus x whole power n plus 1 by n plus 1. You can do the derivative to check that this indeed gives you that, and then you place the limits of 0 and 2. When you plug in 2, you get 3 power n plus 1 by n plus 1. When you plug in 0, you get 1 by n plus 1. So, this is correct. Right, this is correct. Now, all you have to do is break it up. So, 1 plus x whole power n is C0 plus C1x plus C2x squared all the way till Cn x power n, and each of those you are going to raise it from 0 to 2 dx. Okay. And what is that going to give you? C0 dx is C0 times x, alright. Use the limits 2 and 0, you get 2c0. X c1 x is going to give you c1 x squared by 2, and use the limits 0 and 2, you get 2 squared c1 by 2. c2 x squared, you integrate, you get c2 x cube by 3, c2 x cube by 3, you raise it from 0 to 2, those are the limits, 0 will give you 0, 2 will give you 2 cube by 3. Exactly in the same form as we need. And how are we doing this? How did we get our result? We got our result just using some clues. The denominator, increasing denominator, gave me a clue that I need to do an integral. The minus over here gave me a clue that I need to do a definite integral, right. So, those were all my clues. Okay. So, this problem is done. Very good. Let us try another one. This is also an integral, right. The denominator is increasing, but look, it's the sign is alternating. So, maybe you won't do 1 plus x whole power n, you have to do 1 minus x whole power n, right, and then you have to do an integral of that. And look at this, it is just 1 by n plus 1. If you do an integral, you have to do a definite integral, right, because just doing an integral is meaningless, right. The integral of this side, indefinite integrals won't match up. So, you have to do a definite integral, but if I do a definite integral and I plug in x equal to 1, then I get a 0, which means that if I plug in x equal to 0, I am left with 1 by n plus 1. So, if you do work this out, you get the right hand side, and the rest I am going to leave to you, because okay, you need not do 1 minus x, you can even do x minus 1. Let us scratch it out. Let us do integral x minus 1 whole power n dx from 0 to 1. If I plug in 1, if I plug in 1 over here, I get a 0. So, it is 0 minus, if I plug in 0, then I get minus 1 whole power n plus 1 by n plus 1. Okay. And then depending on n odd or even, I either get the plus or the minus of the answer, right. Now, you have to work this out. I am going to leave this result to you. This is not very hard to solve, right. You just have to plug in, you have to expand and integrate, do the definite integral. Okay. Let us try another one. This was a JEE problem some time back. Okay. So, 50. So, these are all we are talking about 50 CR, calling this CR in this particular problem. This is the abbreviation. So, contextual, you can figure it out. C 50 is his last term. So, it has got to be 50 C 50. Okay. So, this is your question. Find the coefficient of x power 49 in this expansion, right, and you have got how many terms? 1, 2, 3, 4 all the way till 50. So, you have got 50 terms, x power 49. What does that mean? That means if I pick this x, then I have got to pick, sorry, I have to pick 49 x's. So, if I do not pick this x, then I have to pick x everywhere else. If I do not pick this x, then I have to pick x everywhere else, which means that the answer is going to be minus C 1 by C 0 times x power 49 minus 2 squared C 2 by C 1 times x power 49 minus 3 squared C 3 by C 2 times x power 49 dot 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 minus 50 squared C 50 by C 49. Okay, that is going to be your the coefficient of x power 49, this whole thing. And how do I do it? C 1 by C 0, this is something again, once again this is familiar, right. We just did something similar. How did we do it? We actually broke it up. C 1 by C 0, we broke up C 1 as factorial n by factorial 1 factorial n minus 1. So, here we are talking about factorial 50, n is 50. So, the rth term in this series, if I pick the rth term, let us say this one, first term, second term, third term, right. Third term starts with 3 square. So, the rth term will start with r squared, and then third term has C 3. So, this will be C r by C 2. So, this will be C r minus 1. C r is factorial 50 by factorial r and factorial 50 minus r, and C r minus 1 is factorial 50 by factorial r minus 1 and factorial 50 minus r plus 1, and then these are going to cancel, 50 50 will cancel out, r minus 1 factorial will cancel out with r factorial and r squared, 1 r will go away, and then 50 minus r plus 1. So, this is larger, 50 minus r is smaller. So, this will completely cancel out with the factorial. So, this whole thing is equal to r times 50 minus r plus 1. Okay. So, that is the rth term. Rth term is r into 50 minus r plus 1. Now, you just have to find the sum of everything with a minus sign. I have ignored the minus sign, all the terms are minus. So, at the end we will put the minus sign in. All right. So, the sum of all of these are all of these terms where each term is r into 50 minus r plus 1. For example, if r is 1, this is equal to 1 into 50 minus 1 plus 1, 50, plus if r is 2, 2 into 50 minus 2 plus 1, 49, plus 3 into 48 plus 4 into 47, plus dot 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 all the way till 50 into 1. Okay. That is what it is. This is the sum that you have to do, and you have to sum it from r equal to 1 to r equal to 50, and then you can break this up. You can break it up as 51, first of all 50 minus r plus 1 is nothing but 51, 51 r minus r squared. And you can take the 51 outside, and sigma of r equal to 1 to 50 is nothing but n into n plus 1 by 2. So, 50 into 51 by 2, and sigma of r squared r equal to 1 to 50 is nothing but n into n plus 1 into 2 n plus 1. So, 50 into 51 into 2 into 50 plus 1. So, 101 by 6. So, this is your answer. Now, you just have to compute this out, right. You can do it. I believe the answer is 22,100, but then eventually you have to place a negative sign. Okay. So, the answer, the final answer is minus 22,100. Okay. Let us do one more. All right. This is also a JEE problem from some years back. Find the coefficient of t to the power 24 in 1 plus t squared whole power 12 times 1 plus t whole power 12 t power 12 times 1 plus t to the power 24. Notice that here this 12 is inside the brackets, this 24 is inside the bracket, which means for these you are not really looking at any binomial expansion. The only binomial expansion is here. Okay. Then notice that you are looking for t power 24. So, if you look over here, there is 1 plus t power 24. So, if you select t power 24, if I select this term, then what will I have to select from the other terms? From here I have to pick 1, and from here I will have to pick 1 in all the 12 terms, right. So, I have to pick 1 everywhere. So, if I pick this t power 24, all everywhere else I have to pick a 1. So, that is one possibility. I am looking for t power 24. Now, if I pick this 1 and not the t power 24, then I am free to pick t power 12 here or not, right. Maybe I will pick, maybe I will not. Let us check. So, if I pick 1 over here now, that is the second possibility. I can pick 1 from here, and then I am looking for the entire t power 24 coming from here. So, 1 over here, and let us pick 1 over here. So, I have already done t power 24 times 1 times 1, that is done. Now, I have picked 1 over here. Then if I pick 1 over here, I can either pick 1 or I can pick t to power 12. Let us pick 1. If I do pick 1, then I have to pick all of t power 24 from the first term, and the only way to make t power 24 in the first term is to pick t squared every time, right. There is only one way of doing that. So, I get a 1 over there. Then I pick a 1 from this last term. The next possibility is I pick t power 12. So, if I pick t power 12 over here, I only need t power 12 out of this 1 plus t squared whole power 12. So, what is the coefficient of t power 12 in 1 plus t squared whole power 12? C 6. Okay, 12C6 is the coefficient of, because you are picking t squared 6 times. If you pick t squared 6 times, so it is 1 plus t squared, 1 plus t squared, 1 plus t squared, 12 such products, right. Out of those 12 products, if you pick 6 t squareds and 6 ones, then you end up with t power 12, right. You are looking for t power 12 out of this, t power 12 you have taken. So, this is your answer, all right. So, this is just reasoning. I think these are reasoning based problems which are quite common in your exams, in your competitive exams. Let us try another one. Okay. So, this is the question, you have to find out what is the answer, right. You have what is the sum of all of this, all of these pairs, and this kind of looks like something that we have done before, although it is very deceptive, it is not the same, right. So, earlier we had done something of this format. This is what we had done a long time back, but notice there is a minus, and these minuses are going to throw a spanner into the works, right, and you will have to solve this all over again. Okay. It is not this, this is not what you are looking for, because if this had been what you are looking for, you will get 60C something, but that is not it, right. There are minus signs here, these are all plus. How will you work this out? And the way to work this out is to look back at the way we worked that one out, because it looks kind of similar, right. So, because it looks similar, we can use the same approach to work with this, even though the answer is not the same. Okay, what was our approach over there? Our approach was, we had looked at x plus y whole power 2n, right, and some coefficient of x power something, y power something else. Okay. We were looking at x plus y whole power 2n in that case. Okay. So, here because of the minus signs, what will you do? Will you work on x plus y whole power 2n or something else? What do you want to do? Minus. So, you are going to work with x minus y whole power 2n. Okay, that is a good start. So, let us work with x minus y whole power 2n. Okay. And what we are going to do is actually not quite this. Okay, we can work with x minus y whole power 2n, and what we are going to do is we are going to break this up into x minus y whole power n and y minus x whole power n, and there is of course a minus 1. Do you want to do something like that? Okay. So, maybe you can do something like this, forget this minus 1 whole power n for now, forget it, right, but let us see if this at all pans out. So, you are going to work out the coefficients of this, right. What will you get? You will get some 2n c something as your coefficient, but what will you get on this? You will get n c something, n c something, right, times a minus, right. What you are going to find is that this alternating sign is not going to come. You will not be able to work out the alternating signs. Okay. You need something little smarter. Okay. What if we do what if we try x minus y whole power n times x plus y whole power n? What if we try that? And by n over here I mean 30. Okay. If you try something like this, x minus y whole power 30, and let us look at which coefficient do you want to look at? Here when we were working with this, we were looking at x power n plus r in this, right. This is you are looking at x power n plus r. So, n in this case is 30, r we have picked is 10. So, maybe you want to look at coefficient of x power 40, maybe. Okay. So, what will happen? How will you generate x power 40? You can pick x power 30 from the first one, and remember we always flip the second one. Okay. So, you pick x power 30 from the first one and x power 10 from the second one. Okay. That is one possibility. Another possibility is x power 29 over here and y power 1 and x power y power 19, x power 11. Then you can do x power 28 y squared, y power 18, x power 12, right, and all of these. So, this coefficient is 30 C 0. This is 30 C 10. So, no y's have been selected. Here 10 x's have been selected. Then the next time I select 1 y and therefore, I get a minus sign. And here I select 11 x's, which gives me 30 C11. Then the next time I select 2 y's, which gives me a plus sign, and 30 C2, and over here I select 30 C12. Okay, so do you see that we have constructed our expression? So our expression will be constructed in this way. Okay. So this is our question. So our question has an answer. The answer is, so if you are asked to evaluate something like this, you construct it in this format, and therefore your answer is the coefficient of y power 20 x power 40 in this expansion. The expansion is x minus y whole power 30 into y plus x whole power 30, and you are looking for the coefficient of y power 20 x power 40. Now, there is an easier way to evaluate this, and that is x squared minus y squared, great, x squared minus y squared whole power 30, correct. And how many x squareds do I need to get x power 40? I need 20 x squareds and 10 y squareds, right. So, the answer is 30 C 20, also 10. Okay, great. So, this was also an interesting problem. We have solved quite a few problems. Thank you very much.